Welcome to Snacks Weekly on Data Science. This podcast is all about making data science and machine learning knowledge accessible and less intimidating. Today's episode is about a problem every fintech company eventually faces: fraud. We are looking at a tech blog shared by Razorpay engineering team titled Meet Bumblebee, the multi-agent AI architecture that changed fraud detection at Razorpay. We will explore how the team moved from manual fraud reviews and early automation attempts to a multi-agent system designed for speed, scale, and reliability. Now, let's dive in. On the business side, let's take a look at the problem to be solved. Razorpay is a full-stack financial service company and payment gateway based in India. So, for a financial company, the trust is core to the business. If risky merchants or fraudulent actors slip through the onboarding stage or remain undetected, that can lead to many problems such as financial loss, compliance issues, and operational headaches. On the other hand, if the fraud system becomes too aggressive, legitimate business may be delayed or wrongly blocked. This creates a dedicated balancing act on how to deal with fraud. According to Razorpay, their risk operations team was manually reviewing thousands of merchant websites every month, looking for red flags such as suspicious pricing, weak policies, misleading claims, questionable domains, etc. Each review took several minutes of human efforts, adding up to hundreds of hours every month. More importantly, manual reviews can be inconsistent between different reviewers. So the challenge for the team was not simply to detect fraud. It was to build a system that could evaluate merchants quickly, consistently, and at scale, while still preserving the nuanced judgments that experienced human reviewers bring. Now that we've understood the business problem to solve, let's shift gear and dive into the technical side to see how the team tackled this challenge. The team shared that they went through multiple iterations before arriving at the final solution. The final production framework eventually became a multi-agent architecture, where different components specialize in different jobs instead of forcing one large AI system to do everything. The three core components were planner, fetchers, and analyzer. Think of this as an investigation team rather than a single detective. The first component is the planner. It receives a merchant case and decides how to investigate it. This is more sophisticated than it may sound, but not every merchant requires the same checks. Some businesses may be low risk and need only a lightweight review. Others may need deeper validation. So the planner creates an execution plan: what data to gather, which tools to use, what should be prioritized, and how much time or budget should be spent on this specific case. The blog noted that it can also enforce business rules, such as skipping GST validation for non-Indian merchants or deprioritizing certain checks depending on the merchant's type. So this is very important because if a naive system ran every possible check on every case, it would waste time and money. The planner helps the system to focus effort where it matters the most. Once the plan is created, the second component comes in: the fetchers. They start gathering the required information. These fetchers are specialized components responsible for retrieving signals from different sources. That may include website data, business details, external sources, etc. The team designed the fetchers to work in parallel based on the needed information. This enables parallel execution and pruning unnecessary data before sending it to the language model. That helped reduce the token usage and latency. Once evidence is collected, the analyzer interprets it and produces final risk judgment. Instead of manually stitching together dozens of fragmented clues, the analyzer can evaluate combinations of signals and synthesize a decision. For example, one weak signal may mean little on its own, but several weak signals together can become strong evidence. That mirrors how human investigators think. With this framework, the team reported significant gains after moving to the new architecture. The token usage of the system dropped by around 60%, and they also observed end-to-end latency improvement as well as success cases increases. Those numbers matters because they represent business outcomes. Lower token usage means lower cost, faster latency means quicker operations, and a higher completion rate means a more dependable system. Now, we've discussed both the business problem and technical solution. Let's wrap it up. In this episode, we discussed a classic problem in fraud and risk operations: too much manual review, inconsistent judgments, and the growing complexity. We explored the solution shared by the engineering from Razorpay, which is a multi-agent AI architecture that separates planning, evidence gathering, and analysis into specialized roles. This enables a robust and scaling system to solve the problem. If you like the content of this episode, please subscribe to the channel. Give me a 5-star review and leave a comment. Your feedback is very appreciated, and I'll see you next week.